TTL Computer 2. Today's a special video for those viewers who are interested in downloading the digital simulation and having a little play with it on their own. And this will show you how to set that up. And if you look in the description of this video, you'll find the links to the digital project, as well as the custom ASM project, and a link to the digital simulator zip file. So you'll have to go through the instructions from digital to get digital set up on your own local desktop, if you haven't done that already. And then you'll have to download and unzip the our TTL Computer 2 simulation zip file. You'll have to unzip that to a local directory someplace of your choosing. And you won't have to download custom ASM. You can use their web tool, would likely be sufficient for your using the starting with the simulator. Okay, so this is the digital program. And again, I'm assuming now at this point that you've downloaded digital, that you've got that all up and going, and we're opening, right? This is your first time you're opening up the simulator, the digital simulation tool, and that you have already unzipped the TTL Computer 2 zip file to a project folder of your choosing, and that's all been ready to go. So we're ready to do like our first launch of the simulator. Okay, so you want to go to File, Open, and you're going to want to make your way to the folder wherever you've installed the TTL Computer zip file that you've unzipped, and you're going to want to open this is our main project file. TTL CPU 2 is our main circuit file, and we're going to just open that up. And there we go. So this should be familiar to you. And but we're not ready to run here because unfortunately, digital doesn't seem to save relative paths for any of its setup files. So they're all going to be pointing to my folder locations. So we need to update that to the local folders that you have created when you unzip the project file. Okay, so, and we haven't really looked at this before, so we've looked at circuit settings a little bit, but you want to go to circuit settings and then advanced. Okay, and then when you see where it says here, content of ROMs. So what we're going to do is we need to hit edit here. All right, and here's our series of ROMs that we have, right? Here's our control ROM 1, 2, and 3, and then this one that says ROM 1. That's our main memory ROM file. So what we need to do is, and you can see that there's a file associated with each of these ROMs, and that's basically their contents. So we're going to want to do that, and these are already all done, but we'll do one here as an example. So here's the ROM 1 file. I want to click, this is the current file, and want to change that. All right, so again, you should be looking at this same set of files wherever you unzipped your simulation project. And we want to take, right, these hex files are the binary files that we need for our all of our ROM modules, right? And this was ROM 1, so that's ROM 1. What the heck, we'll go through and do these. What do I do here? Cancel. You want to edit that, right? ROM 2, okay, and do the same thing for ROM 3. Edit, right? Want to pick ROM 3, okay, and then this last one again. Now this is our main ROM file, so this is going to be like the initial program that the computer is going to run, right? Because it starts running the program, the computer starts running at address 0. So that's going to be this ROM file. So we want to edit that. Okay, so I've included 2 files for you here. One is test.hex and the other is monitor.hex. So all right, we'll do the first one. Let's pick test. We'll say okay. You want to say okay here, and then I would click save to save the settings that you just did. Okay, so we're good to run this now. Let's start our simulation. And you see that the keyboard object, the digital keyboard object popped up. We don't need it for the test program, but let's hit reset. And now our test program, our test harness is running. And I think we're running at a high clock speed here, but we can see that the test program is running. All right, let's stop that. Let's edit again to advanced, edit. All right, let's change our main ROM, which was pointing to the test harness. Let's edit that. And let's point to the monitor hex file. Say okay, 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 and let's again click save. All right, so we're ready to run this. I'm going to start the simulation. Now we see again, this is our keyboard object from digital, and hit reset, right, and that really starts our program. All right, now to be able to type here, you can't type into this window. You have to put the keyboard, click into the keyboard where it says enter text. Just click that, and that puts the focus on the keyboard, the focus of your cursor. So then the terminal will respond, right? Question mark, right? We could do dump memory address 0, and this is going pretty slow. So I'm not sure what the clock speed was I had set up for you in the package that you downloaded, but let's stop this. Where are we here? Oops, what's going on? Let's change the clock frequency. If you're going to use the monitor, I'd set it up at 50,000 hertz. Okay, you hit run again. And here's our keyboard. Hit reset. Okay, now this is running pretty good. Put your focus down here on the keyboard object. And then, all right, so this is running faster now. Dump address 8000. Okay, period to end that. Let's do go or jump address 0. That's the beginning of the monitor. Let's modify memory, address 9000, and 39 is our opcode for var jump, and then 00. Okay, and then we can jump to address 9000, and right, that just jumps to the beginning of the monitor. Okay, so that's the distribution that you have. I also distributed, you can discard these changes. I've also changed this to all files. I've also given you the source code for the test harness, the assembler file. So that's in the distribution. Right, that's here. It's a pretty large file. But what you can do is open this in an editor and copy the whole contents of the file and go to the custom ASM site, which is this. Whoops. I'll provide you the link here to their website. And this is the sample program they have. Just delete that all, paste in the test harness code or your own code if you want to start, try doing some code of your own. But you see in the beginning here, these are some bank definitions. This is all of our instruction set definition, right? Here I'm saying I want to configure this to start the code in the ROM bank, and then this is the start of our program. So you could change all this code to your own code to start playing around with the assembly development for the computer. Okay, So then you get that loaded in there. You want to set the output format to LoGSIM 8, right? And then assemble. And then if you have errors, you'll get the errors here, but when it's successful, you'll get just a output like that. You're going to want to copy this whole thing, copy that, and then paste it into whatever file that you want to call it, my first program.hex, whatever it is. Save that to the same location that you unloaded, unzipped the project files to, and then you can just do open the simulator project. No, we don't want to do that. We want to do circuit specific settings again, advanced, right? And change this to whatever hex file that you just made where you saved the output from Customasm. You would just pick that here, and then you are good to launch your own TTL2 computer program. Okay, so that's it for today. You should have enough information to get your own TTL2 computer simulator up and going, and I look forward to reading some of your comments in the video comments. So until next time, that's it. Thanks for watching.